Water, a remarkable molecule. Okay, so I already explained this to you, but here we go again. So here, graphing the period of X for a compound with the formula H2X. This is dihydrogen sulfide, dihydrogen selenide, dihydrogen telluride. If we graph their boiling points, we see that there's a trend here. They're not forming a perfect line, but there's definitely a trend going on. Let's see if I can make a red line. Oh, iPad. Still haven't come up with a name for it. It needs a name. So there's some sort of a trend there, right? So if we were just looking at these and we're trying to predict the boiling point for the compound made with the period 2 element, we would predict that its boiling point would be minus 100. But it isn't. It's plus 100. That is huge. That is a huge discrepancy. And it's because of hydrogen bonding. Water is very polar. It's just hydrogen and oxygen, very polar bonds. And because it's so polar, it works very well to dissolve other polar and ionic compounds. So we sometimes call water the universal solvent because it dissolves so many different things. Water is the main solvent of living organisms. Your body contains a lot of water. Water is the solvent for most of the solutions in your body. Your blood has water as the solvent, and it's got lots of other things dissolved and floating around in it. Life is impossible without water. And most places on Earth where you find liquid water, you're going to find life. And water is one of the things they are looking for when they're going out into space and looking to see if there's possibility of life somewhere else. Is there any water? If they find water, and they apparently have found some recent evidence of water on Mars, gets everybody all excited that maybe there is or was life on Mars at some point. The way that water freezes is very unusual. Most substances, when you go from a liquid to a solid, they become more dense. They actually shrink or contract when they freeze. Water doesn't do that. Water expands when it freezes. And this results in ice being less dense than liquid water. So ice cubes float, icebergs float. See, here's my rock star, and the ice cubes float. We know that, right? And we've experienced some of these things. Water actually reaches a maximum density at 4 degrees Celsius, which is slightly above freezing. And then as you get it colder and colder, it becomes slightly less dense. So this is really important in places like Minnesota. I grew up in Minnesota and Iowa. And in Minnesota, the tourism industry is really big, and fishing, because it's the land of 10,000 lakes. It's actually, they have way more than 10,000 lakes, but when it got that name, nobody knew all of them because they couldn't fly over and see them all. Just crazy how many lakes there are there. It also gets really, really cold in the winter, like minus 40 sometimes. Not wind chill, absolute temperature. I remember those days. I don't miss cold temperatures like that. But the lakes freeze. The lakes freeze over. But that frozen layer of ice, because it's less dense, it stays at the top. And it insulates the water in the rest of the lake from freezing solid. If ice was more dense, so we understand that you get down a little bit in the earth and the temperature is sort of moderated, but up on the surface the temperature can fluctuate greatly. So up at the top of the lake, it's minus 40 degrees, the water's going to freeze. As it freezes, if it was more dense, it would start to sink, and the lake would freeze solid. That would kill all the fish. That would devastate the fishing industry. So That doesn't happen though. Water is less dense. This also causes things like pipes bursting. If you have pipes, even big old metal pipes, not just the plastic ones, but metal pipes, and they freeze solid with water in them, the water expands and it's incredibly powerful, and it will crack open metal pipes. Ice expanding is one of the reasons that they have so much trouble with the roads in Minnesota. The joke is there's 2 seasons in Minnesota, winter and road construction. Because what happens is you get any little cracks in the road and moisture gets in there, and when it freezes, it expands. And so you've got this constant expansion in these cracks, and it just does a number on the roads. So anytime when the earth is not frozen, they're out there fixing the roads. And it's really kind of true. They're doing road construction all summer. The other thing that can happen is if you put something in the freezer. So you've got a water bottle, brand new water bottle, unopened, and you're like, I'm going to be out all day tomorrow, and I won't be, I want this to stay cold, so I'm just going to freeze it, and that way by the time I need it, it's going to be good. Is that a good idea to freeze a full water bottle? No. I think most of us have experienced that. It breaks. As it freezes, it expands, and it breaks the water bottle, right? It happens. So if you're going to freeze something like that, you need to leave some space for it to expand. Okay, so there's practical aspects to this chemistry lesson. Where are we going with this? Oh yeah, see, I jumped ahead of myself again. Why do things die? Especially plants. Why do they die when it freezes? Well, there's water in their cells. And when that water in the cell freezes, it expands and ruptures the cell. That's why a lot of plants, you get that first frost and they're just like wilted lettuce on the ground. What happened to you? Well, all of its cells burst. You'd do that too if all your cells burst. There are a number of foods that don't survive freezing very well. What happens when you freeze strawberries and you thaw them out? They're all mushy, right? Now, you can still do stuff with them, but they're not going to taste the same. So some foods don't freeze well. People don't freeze apples. This is not a good idea, right? It's going to be nasty when you thaw it out. There is a technique that they use in industry called flash freezing. And here they freeze the fruits and vegetables so quickly that the cells, the molecules in the water can't line up and form this expanded crystal structure that they usually do. It freezes so fast that it doesn't do that. And that's the end of the chapter. There we go. All of a sudden,